we are now going to start lesson 9.4, which is solving quadratics by finding square roots. So far in our semester, we have already learned 2 ways to solve a quadratic: factoring, which we kind of started back in chapter 8, and we reviewed last week. And then last week we also discussed how to solve while graphing. We're going to add 2 more methods this week, and the first of those methods is finding square roots. So before we actually get to the process of solving a quadratic with that, let's kind of review what it means to have a square root, where those buttons are in your calculator. Then we can move into actually using it as a tool for solving. So first off, I know it says bell work, but if you wanted to go ahead and get out the calculator you think you're going to use so we can practice entering these items in. All right, so if we do the square root of 25, your calculator should just give you a 5. The reason that works out so nicely is because 25 is a perfect square. So sometimes our answers are very simple, just like that. However, with solving quadratics, we're going to have a lot of times when the number under the radical, not a perfect square. So for example, here on example B, when you do the square root of 20, I believe you get something like 4 point, I'm just going to give a few decimal places here, 472 ... This is kind of a gross number. We are going to accept these answers, and we'll tell you what to round to. We're going to go nearest hundredth, I believe. However, I would also like to show you how you can simplify this to get an exact answer. That's something that your Khan Academy is going to have you do, trying to put things in an exact answer versus an approximated answer. So I would like you to understand how your calculator, if you have one that does this for you, how your calculator simplifies the radical. So we're going to get back up to example 2 here in a second, but let's kind of go through our properties of radicals. So the radical is the symbol we use as our square root. We have 2 properties. The first of these properties is called the product property. It states that if I have the square root of a product, I can separate that product out into 2 factors that make up that product. So let's practice this with the square root of 20, which we were using up there in example, in our bell work example number 1. So if we look at the factors of 20, that would include 1 and 20, 2 and 10, and 4 and 5. When you simplify a radical, you're looking for perfect squares. So of the numbers here that are perfect squares, that would include 1 and 4. And your goal is to use the largest pair, or the largest one. 1 really doesn't get us anywhere anyways, so while it is a perfect square, it's not going to help us much in this situation. However, 4 is also a perfect square. So what we have determined is that allows us to separate this 20 out into 2 of its factors, in this case 4 and 5, and simplify the factor that is a perfect square. So the square root of 4 is 2 radical 5. So for those of you that have the calculator that does this for you, if you put the square root of 20, it is very possible, instead of giving you the decimal, it would have told you that the value of this is 2 radical 5. That is the exact answer. The first one is the approximated answer. So we are not going to be particular on which type you give us. However, I want you to be able to know how both are achieved. All right. So going along with that, we are going to now cover our other property, and let's do a few examples that go with. Actually, let's skip to example 1. We'll come back and do our other property and then look at example 2. So let's kind of practice this process again. How do I simplify a radical if it's not a perfect square? So if you do the square root of 50, it is not going to give you an exact value if you are on a calculator that doesn't simplify for you. So your goal would be to say, all right, what are the factors of 50? That would include 1 and 50, 2 and 25, and 5 and 10. Of those, again, 1 is a perfect square, but it's not going to help us out in the situation. But so is 25, because the square root of 25 is 5. So the pair we would like to use to simplify the square root of 50 is 2 and 25. So if we rewrite 50 as 25 times 2, doesn't matter which one you write first. I personally like to write the perfect square part first, since I know it's going to simplify. So the square root of 25 is 5, and radical 2 doesn't simplify, and it stays. So the square root of 50 is the same thing as 5 times the square root of 2. All right, let's do it one more time here with this 48. I like this example because 48 has multiple perfect squares that go into it. So if we write those out, we have 1 and 48, 2 and 24, 3 and 16, 4 and 12, and lastly 6 and 8. So again, 1 is there, but it doesn't help us out. 16 is a perfect square, and so is 4. So we kind of go down our list there. We have 3 options. Again, if you're simplifying this by hand, your goal is to find the pair with the largest perfect square. So in this particular case, that would be the 16. If you don't choose the largest, it's not like you're going to not be able to get to the simplified form. It just means you're going to have extra steps. So we're going to rewrite the square root of 48 as the square root of 16 times the square root of 3, which simplifies to 4 radical 3. And I know that C is there, but it is the duplicate of what we did above. So that is how we use the product property of radicals. Now, in case you're wondering, does my calculator do this? Hopefully it would have already happened if you already had it out. But it's this calculator here. They have you get it in 8th grade. If this is the calculator you have, it should simplify radicals for you. If you're needing it to go to the decimal form instead of the radical form, there is a button located right down here that allows you to go back and forth between your exact and your approximated answers. All right, the other property that relates to radicals is our quotient property, meaning if we have the square root of a fraction. This one shouldn't affect what we're going to do today very much, but it will come into play when we start looking at potentially the square root of, when we're doing our when we're doing completing the square. And so this will come up in the next few weeks, maybe it's not today on this set of notes. However, it is a property that says you can't leave a fraction under a radical. So to simplify that out, you can just go ahead and look at the radical of both your numerator and your denominator separately and simplify from there. So if I want to do the square root of 3/4, that is the same thing as the square root of 3 divided by the square root of 4. And then I simplify what I can. So this should give me the square root of 3 over the square root of 4, which is just 2. And that would be the simplified version of the square root of 3/4. Again, they're both equivalent. They would give you the same value if you determined the approximate amount. Here's an example of a fraction where the whole fraction is not underneath. However, the top of our fraction, this is something you'll use in your quadratic formula lesson. The top of our fraction simplifies. We're going to borrow the square root of 20. Its simplification is 2 radical 5. And I provided this example to show you that you can't combine things under the radical with items that are not. So when it comes to simplifying, I can't combine this 4 and this 20 because of the location of the radical. However, once the square root of 20 is simplified, it does allow me to go ahead and simplify this fraction. So if I simplify 2/4, that should go, 2 goes in here once, in here twice. So the simplified version would be the square root of 5 over 2. Last but not least, sometimes when you have a radical over a fraction, it's in your best interest to simplify the fraction before you separate it out. So in this particular case, 32 over 50 does simplify to 16/25. Hopefully you're kind of noticing, hey, those are both perfect squares. So this should work out really nice once we simplify or separate it out. So the square root of 16 is just 4, and the square root of 25 is 5. So that is kind of just a little bit of a review, and or it might be new to a lot of you, how to simplify a radical. All right, which brings us to actually using square roots to help us solve a quadratic. So I'm going to go back up here to our bell work. Sorry to kind of bring you around the page. It's important to note that there are several ways you can solve quadratics. So figuring out which type works is important, and you'll notice that's in one of the homework assignments this week. So let's kind of review a method we already know and how to use it to solve, and then let's apply a different method, and then you can start to determine which methods you prefer, or which ones might be the quickest depending on what you have. So here we have a quadratic, meaning we have a largest exponent of 2. When we solve by factoring, our goal is to set it equal to 0 so that we can use our zero product property. So to get this factored, it is a green light. So I'm going to go ahead and do that over here on the side. We have a negative 81, and we're looking for factors that add up to 0. Now you may wonder, why is it a 0? We don't have an x term here. It's just x squared minus 81. This is technically a difference of squares. So if you didn't want a green light and you recognize the difference of squares, you could factor it straight into that. Since it's going to add up to 0, that kind of leads us to the fact that the factors we're looking for need to be opposites. In this case, it's 9 and 9. One of them needs to be negative so that we get the desired result. So the factored form of x squared minus 81 is x plus 9 and x minus 9. Then if we apply our zero product property, meaning if these two sets of parentheses multiply to be 0, one of them has to be a 0 for that to be a true statement. And the x values that get us there are positive and negative 9, which we can condense down and just write with this symbol. We call it a plus or minus. And that means positive 9 or negative 9 can be the solution. All right, I think that rounds out our front page of notes. A little nice review of how to solve by factoring before we tackle our third method for solving a quadratic. All right, so solving by taking square roots. You're going to notice, based on standard form of a quadratic, that when you can use this method, the only parts of the quadratic that you're going to see are the squared term, our ax squared term, and our c term, or our constant term. So if you wanted to write in here when this method is doable, or when you can use it, that's what you're looking for. So this method works when the bx term is technically 0, or we can just say isn't present. Now there is one exception to this, and we'll get to it down here in example 3. All right, so in the process of trying to solve what you're going to do first, or step one, is going to be to isolate that squared term. So our goal is to get the x squared all by itself with a 1 in front. This means that all the values that are on the other side are a combination of whatever C was and whatever A might have been that have now all been moved to the other side. So before we start actually doing this process, let's discuss what results we can expect to see. Since a quadratic is degree 2, the most solutions we could have is 2. And that is going to happen when this D term is positive or greater than 0. So we're going to expect 2 solutions when we have isolated our x squared and we know that the value that remains is positive. Now, the way we're going to get those solutions, and we're going to review that from what we just did on the first page, is we're going to take the square root of D and we're going to use this plus or minus sign to represent our 2 solutions. Now this plus or minus gets left off sometimes, and we'll talk about how to try to remember that. But that's how those 2 solutions will present itself. All right, the second option that could happen is that we'll get our x squared term isolated, and what remains on the other side is a 0. In that particular case, we're going to only have 1 solution. Sorry for this random little O that's sitting here. I'm going to go ahead and white that out so you don't see it. Last but not least is something that we can't, or that we're not going to tackle this year in Algebra 1, is what happens if I move everything and the remaining amount is negative or is less than 0. So for this year, if this happens, and it's going to give you an error in your calculator, but if this happens, you're going to write no real solution. When you progress to Algebra 2, you're going to learn about the complex number system and what we like to call imaginary values or imaginary units, and that's going to assist you to actually get an answer there. But for right now, we're just going to state it as no real solution. So if your calculator gives you an error, or you recognize that your x squared term is equal to a negative value, then that will be the result. All right, so let's go ahead and apply what we know. Woo! So example number 3, we would like to know what term squared equals 4. Now, you may already be thinking in your head you know exactly what this answer is, and sometimes that's the case when it comes to solving a quadratic. You may be able to figure this out without actually solving. But I purposely started with a simple problem so we could work out how the steps work. So step number 1. We want you to isolate the x squared, or whatever variable it is. Meaning its leading coefficient is a 1. So if a does not begin as a 1, we want it to be a 1 after we've moved everything away. In this particular case, that has already happened. So x squared in this problem began already isolated. Now, solving in math is a lot of compilation of just trying to use the inverse to get a variable on its own. So we're going to add an inverse in today. The inverse of squaring something is to take the square root. So in these particular situations where solving by square roots is an option, that is why the square root becomes important. So we're going to take the square root and not to leave it out, but of both sides. So remember, when we're solving, whatever we do to one side, we must also do to the other. All right. So we go to take the square root of both sides. When we square root the x squared, all that remains is the x. So in essence, the radical and the 2, they neutralize each other. When we square root 4, we get 2. However, and we even stated up above, do not forget, 2 is not the only number when squared that gives us a 4. So yes, a positive 2 squared does give you 4. However, assuming you enter it in your calculator correctly, a negative 2 squared, or negative 2 times negative 2, also gives us 4. So when we solve by square roots, whenever this value right here is positive, we have to remember to apply our plus or minus. So when this number is positive, we have to remember to put our plus or minus. So when that number is positive, actually let me go ahead and write the word positive in. And that's just a little review of what we had above, but just to kind of put it in the example right here so you see it. All right, and that's how you solve using square roots. Now, square roots doesn't work for every quadratic. It only works in this particular situation, but when it can be used, it is actually a very fast method. All right, I'm going to copy over my steps here to example B. And let's work them through. So first step, to isolate. Now in this one, we actually have some steps to do. So this is the part that we want to get by itself, which means I need to move this negative 48 and I need to move this 3. By order of operations, we kind of almost do it in reverse. We want to move this 48 first. So I'm going to add 48 to the other side. That should give us 3x squared equals 48. However, I also want to make sure it's a leading coefficient of 1. So I'm going to divide by 3. Our isolated piece here should just be x squared equals 16, which is what 48 divided by 3 is equal to. We now have it set up to take the square root of both sides. We square root an x squared. Again, the radical neutralizes the squared, leaving us just with x. 16 is positive, so we should expect 2 solutions. Square root of 16 is 4. And because this was a positive number, we want to make sure we don't forget our plus and our minus. All right. Now, as I said earlier in the video, there is one exception to the setup where we have something where the square root works, but it looks a little bit different. So I want to show you that here on example C. So what you'll notice is the part that's being squared is a little more complicated. We call this a quantity, meaning we have something inside the parentheses using a minus or a plus. When we have a quantity squared, square roots will work. So if you wanted to write that in here, you can. So solving by square roots works. Now, I'm not going to lie. When I first started learning it, it took me a long time to remember that that was an option. But it is definitely the fastest way in which to tackle this particular problem. All right, so I'm going to write our steps back down. So let me go ahead and copy those real quick. When we isolate and we're working with a quantity, it looks a little bit different, but the goal is still the same. We want to get the quantity by itself. In this particular case, it is. There's nothing outside the parentheses other than the squared. So the isolation step has been done for us. So I'm just going to rewrite it. And then our goal is to take the square root of both sides. Now when dealing with a quantity, we're actually going to have an extra step at the end, but we'll talk about that here in a second. All right, so when we square root this, again, it neutralizes that squared. However, this one has a little bit extra left. So this x minus 3 is what remains. For those of you that want to simplify this 75, I'm going to do this over here to the side. The square root of 75 simplifies to the square root of 25 times 3, which is 5 radical 3. So if you were aiming for an exact answer, the square root of 75 would give you 5 radical 3. And remember, since 75 was positive, we have two solutions. That would be a plus or a minus. I will finish this problem out here in a second with how you'll tackle it if you do an approximate answer. Now, because of the fact that we had a quantity to begin with, we actually have a third step. So step 3, when you're dealing with a quantity, is just to keep solving. Because since we had the quantity, it means that x is not going to be by itself. So the last step here is going to be add 3 to the other side. So your final answer, and we always write that number in front, should be 3 plus or minus 5 radical 3. That's what you would get if you were leaving this in an exact answer. Now, should you want to leave this in an approximate answer, here's how you could type it in. And I'm going to use my Desmos because that's what's on my iPad. So I'm going to show you with Desmos. There isn't really a plus or minus button, which means you have to evaluate each one separate. So we had 3 plus the square root of, let me back that up. 3 plus 5 times the square root of 3. That would be your first answer. So if you're going without the approximate, or if you're doing an approximate answer, you're going to enter the plus and the minus at separate times. So your second number should be 3 minus 5 radical 3. So if you were going to give an approximate value, you would need to write out two separate solutions. The first of which is 11.66. And the second is a negative 5.66. Now, you may think, hey, if I left it exact, I actually didn't get two answers. And the answer is, the fact of the matter is you actually did. The plus and the minus, they represent your two values. So you can write it more condensed. If you decide to do a more approximate answer, you need to write out both separately. All right. So last but not least. So we're isolated. I'm just going to do this one real quick. We take the square root of both sides, but you're going to notice your calculator gives you an error. So if you're forgetting about what happens and the error jogs your memory, that's when you're going to write no real solution. Okay. I know we didn't have one that was gave you one solution, but you may come across that